Okay, and for number 39, let's see, we have 6x squared minus 4x minus 80 is equal to 0. And again, we want to reduce our quadratic into lowest terms so we can have smaller numbers. And all of these numbers here are divisible by 2. So we have 3x squared minus 2x minus 40 is equal to 0. Next, we want to identify what a, b, and c are. A, b, and c. So we have that a is equal to 3, b is equal to negative 2, and c is equal to negative 40. So plugging into our quadratic formula, our variable this time is x. So we have x is equal to negative b, so negative negative 2. It's going to be positive 2, plus or minus the square root of b squared, so negative 2 squared is 4, minus 4 times a, which is 3, times c, which is negative 40, all over 2a, so 2 times 3 is 6. And so putting our discriminant into our calculator, we'll have our 2 plus or minus the square root. And in our calculator, this is going to give us 484 all over 6. So something that's useful to do is when we have big numbers is just take the square root of it in your calculator. If you get a decimal, then it's not a perfect square, and you should try dividing this number by perfect squares. However, the square root of 484 is actually equal to 22. So that means that we can replace this 484 with 22, and we get 2 plus or minus 22 all over 6. Of course, this means that we have two solutions here. We have 2 plus 22 over 6, and we have 2 minus 22 over 6. Evaluating these, this is 24 divided by 6, which is equal to 4. And then we have 2 minus 22, so that's going to be negative 20 over 6, which is equal to negative 10 over 3. That means that our x values, we have x is equal to 4, or x is equal to negative 10 over 3. All right, so for the next one, we probably have enough room. All right, smaller, a little bit. So for number 40, we have 5x squared minus 2x plus 9 is equal to 0. This quadratic is already in lowest terms, so we can't reduce it anymore. So now we just have to identify a, b, and c. We have that a is equal to 5, b is equal to negative 2, and c is equal to 9. So when we plug into our quadratic formula here, we have x is equal to negative b, so negative negative 2. It's going to be positive 2 plus or minus the square root of b squared, so negative 2 squared is going to be 4, minus 4 times a, which is 5, times c, which is 9. So the square root of all that, all over 2 times a, so 10. So putting our discriminant into the calculator, we're going to get 2 plus or minus the square root of negative 176 all over 10. So remember, with the square root of a negative number, we always get an I out of this. So the square root of negative 176 is going to be the square root of 176 times I. But what we also want to do is check, is 176 divisible by any perfect squares, so that we can hopefully make this a smaller number. And it turns out that it is. The biggest perfect square that 176 divisible by is 16. So 176 divided by 16 is 11. And the square root of 16 is 4, which means that the square root of negative 176, when we put all this together, we have 4 square root of 11 times I. So over here, we can now replace this with 2 plus or minus 4 square root of 11 times I. Something to note is that this I is outside of the square root. That's why I put a little dot here to signify that this is square root of 11 times I. So, side note, this is incorrect. Do not write square root of 11I. The I is not under that square root. So just wanted to note that real quick. But we have all of this divided by 10. And the last step is just seeing if we can divide 2, 4, and 10 by the biggest number possible. That number is 2. And so we get 1 plus or minus 2 square root 11 times I all over 5. And it's perfectly acceptable to leave your answer as this. So it's okay. You do have 2 answers here. Just generally, if the only difference between your 2 answers is plus or minus, it's usually when we have like a square root of a number here, and this doesn't reduce into nice numbers like we had over here in the previous problems. We do have that x is equal to 1 plus 2 square root of 11 times I over 5, and x is equal to 1 minus 2 square root of 11 times I over 5. It's just, this doesn't really add to our understanding of our solutions. The only difference being is that this is a plus and this is a minus. So it's very common to see your answer written just as this compact form of only a plus or minus here. So this is the way that you'll normally see it if it doesn't reduce into rational numbers like 4 and negative 10 over 3. Now, if you get rid of a square root here and you do get a rational number, it is best to break it up like we did up here and in the previous problems. But if we still have a square root left over, just leave it as plus or minus, and that will be okay. So let's look at the next one. Now we have number 41. So with number 41, we have 7n squared plus 4n minus 6 is equal to 0. We can't divide all of these numbers by some other number, so this is already reduced as much as we can. So we identify our a, b, and c. We have a is equal to 7, b is equal to 4, and c is equal to negative 6. So plugging into our quadratic formula, in this case our variable is n. So we have n is equal to negative b, so negative 4, plus or minus the square root of b squared, so 4 squared is 16, minus 4 times a, which is 7, times 6, which is negative 6, all over 2a, so 2 times 7 is 14. And now we evaluate what our discriminant is. So putting all that into your calculator, you'll have your negative 4 plus or minus, and this will be the square root of 184. Of course, this is all divided by 14. So the square root of 184, we try to divide that by the biggest perfect square we possibly can, and turns out that that is the biggest one that we can divide by is only 4. And so if we divide 184 by 4, we get the square root of 46. This is a 2. So that's equal to 2 square root of 46. We can rewrite this now as negative 4 plus or minus 2 square root of 46 all over 14. And the biggest number that we can divide negative 4, 2, and 14 by is 2. And so, final answer gives us negative 2 plus or minus the square root of 46 all over 7. And so this is our final answer. For the next one, number 42, we have 7x squared plus 8x plus 5 is equal to 0. We can't reduce this anymore. So we have 7, 8, and 5 as our a, b, and c. So a is equal to 7, b is equal to 8, c is equal to 5. And plugging into our quadratic formula, our variable here is x. So x is equal, negative b is going to be negative 8, plus or minus the square root of 8 squared, so 64, minus 4 times a, which is 7, times c, which is 5, all over 2a, so 2 times 7, we have 14. And evaluating our discriminant, we'll have our negative 8 plus or minus the square root. And putting all this into our calculator, we'll get negative 76 all over 14. So, again, we have the square root of a negative. So square root of negative 76 is going to be the square root of 76 times I. And then we want to see if we can divide 76 by a perfect square to reduce this. So the biggest perfect square is actually just 4. So 76 divided by 4 is 19. Square root of 4 is 2, which means that this is all equal to 2 square root of 19 times I. So we replace our square root of negative 76. We have negative 8 plus or minus 2 square root of 19 times I all over 14. And the biggest number that we can divide 8, 2, and 14 by is 2. And so we get negative 4 plus or minus the square root of 19 times I all over 7. And so this is our final answer. For number 43 now. Paper. Okay, there we go. Make sure everything's in frame. So for number 43, we have 2n squared minus 56 is equal to negative 6n. So this one and the ones following it are all not in standard form. Remember, our standard form has to be ax squared plus bx plus c is equal to 0. And so because we have this negative 6n on the right side of our equal sign, we want to move it over. And we'll do that by adding 6n to both sides. When we do that, we'll have 2n squared plus 6n minus 56 is equal to 0. And then we also want to see if we can reduce this, and it turns out that 2, 6, and 56 are divisible by 2. So if we divide everything by 2, we get n squared plus 3n minus 28 is equal to 0. So now we have to identify what a, b, and c are. Remember, this is implicitly a 1 here. So we have a is 1, b is 3, and c is negative 28. And plugging into our quadratic formula, we have n is equal to negative b, so negative 3, plus or minus the square root of b squared, so 3 squared is 9, minus 4 times a, which is 1, times c, which is negative 28, all over 2a, which is 2. We evaluate our discriminant, so put that into our calculator, and we'll have the square root of 121, so all of that over 2. And we may recognize that the square root of 121 is just equal to 11. So this one works out pretty nicely. So negative 3 plus or minus 11 over 2. And since we have rational numbers here, we don't have any more square roots, we actually want to state what both of those solutions explicitly are. And that's why we break it up as negative 3 plus 11 over 2 and negative 3 minus 11 over 2. When we do that, we have negative 3 plus 11, so that's going to be 8 over 2, which is 4. And then we'll have negative 3 minus 11, which is negative 14 over 2, which is negative 7. Which means that we have n is equal to 4, or n is equal to negative 7. And so these are our two solutions. Let's look at number 44. For number 44, we have 2x squared plus x is equal to 3. And rewriting this in standard form, we need to subtract 3 from both sides. When we do this, we have 2x squared plus x minus 3 is equal to 0 now. So, no greatest common factor between 2, an implicit 1 here, and 3. So we can identify a, b, and c. We have a is equal to 2. B is equal to that implicit 1 right here. And c is equal to negative 3. Plugging into our quadratic formula, we have x is equal to negative b, so negative 1, plus or minus the square root of b squared, so 1 squared is still 1, minus 4 times a, which is 2, times c, which is negative 3, all over 2a, so 2 times 2 is 4. Calculating our discriminant, we put this into our calculator, and we're going to get the square root of 25. And we know that the square root of 25 is equal to 5. So this is equal to negative 1 plus or minus 5 all over 4. Since we don't have any square roots left over, we have just two rational numbers. We have negative 1 plus 5 over 4 and negative 1 minus 5 over 4. Calculating these out, negative 1 plus 5 is going to be 4. So 4 over 4 is 1. And then negative 1 minus 5 is negative 6 over 4. It's going to be negative 3 over 2. And so we have that x is equal to 1 or x is equal to negative 3 over 2. Let's look at number 45. So with number 45, we have 10x squared is equal to negative 4 plus 4x. And this is not in standard form. So we want to move this negative 4 and this plus 4x over to the left-hand side, which means we will add 4 and subtract 4x from both sides. That's going to give us 10x squared minus 4x plus 4 is equal to 0. Then we want to check if 10, 4, and 4 are divisible by any numbers. The biggest one that all of those are divisible by is 2. So we have 5x squared minus 2x plus 2 is equal to 0. We identify our a, b, and c. We have a is equal to 5, b is equal to negative 2, c is equal to 2. And we plug into our quadratic formula. We have x is equal to negative b, so negative negative 2 is going to be a positive 2, plus or minus the square root of negative 2 squared, or b squared. So that's going to give us 4, minus 4 times a, which is 5, times c, which is 2, all over 2a, so 2 times a is 2 times 5, which is 10. And so, evaluating our discriminant, we have 4 minus 4 times 5 times 2, putting that into a calculator, and we're going to get square root of negative 36, and then all of that is going to be over 10. So, square root of negative 36 is the square root of 36 times I, and the square root of 36 is 6, so we just have 6i, meaning we can replace our square root of negative 36 with just 6i over 10. So, last thing we want to do is we want to check if we can divide any of these numbers by some number. So 2, 6, and 10 are all divisible by 2, which means we have 1 plus or minus 3i over 5. So while this one doesn't have any square roots in it, it does have an I. So just like before, there's no real reason to separate this out into two separate answers. We can just keep it as plus or minus and be done with it. Let's look at number 46. So for number 46, we have 5x squared minus 9 is equal to negative 3x. Not in standard form. So we need to move this negative 3x over to the other side, and we'll do that by adding 3x to both sides. So we'll give us 5x squared plus 3x minus 9 is equal to 0. We can't divide 5, 3, and 9 by any common factor. So we just need to identify what a, b, and c are. In this case, we have a is equal to 5, b is equal to 3, and c is equal to negative 9. Plugging into our formula, we have x is equal to negative b, so this is going to be negative 3. Plus or minus, we have b squared, so 3 squared, which is 9, minus 4 times a, which is 5, times c, which is negative 9, all over 2a, so 2 times 5, which is 10. We have our negative 3 plus or minus, and we want to figure out what our discriminant's going to be. We plug all that into our calculator, and we have the square root of 189, and that's going to be all over 10. So let's see if we can break down the square root of 189. And turns out we can. 189 is divisible, the biggest perfect square that it's divisible by is 9. And so our other number, if we do 189 divided by 9, that's going to be 21. So square root of 9 is 3. So this is equal to 3 square root of 21. So we can replace our square root of 189 with 3 square root of 21. We have negative 3 plus or minus 3 square root of 21 all over 10. And for this one, they're not 3, 3, and 10. They're all what are called coprime. So there's no number that we can't, or that we can divide all of them evenly by. So we can leave our answer like this. And so that is our final answer for number 46. We have 2 more. For this video, at least. We have like 230 something more. 228 more, so that's fine. So 47, we have 4x squared is equal to negative 5 minus 6x. Let's see. All right, well, not in standard form. So we want to add 5 and add 6x to both sides. We get 4x squared plus 6x plus 5 is equal to 0. 4, 6, and 5, they don't have a greatest common factor, other than 1, but it's not going to help us. So now we have a is equal to 4, b is equal to 6, and c is equal to 5. Plugging into our formula, we have x is equal to negative b, so negative 6, plus or minus the square root of b squared, so 6 squared, which is 36, minus 4 times a, which is 4, times c, which is 5. All of that over 2a, so a is 4, so we have 2 times 4, which is 8. And now we want to evaluate our discriminant. So we have our negative 6 plus or minus the square root. And putting all this into our calculator, this is going to come out to negative 44 all over 8. And the square root of negative 44, again, we have the square root of a negative number. So this is the square root of 44 times I. And square root of 44, that one, I think it's pretty clear, is divisible by 4. So we get 4 and 11. Square root of 4 is 2, meaning that our square root of negative 44 gives us 2 square root of 11 times I. So replacing our square root of negative 44, we have negative 6 plus or minus 2 square root of 11 times I all over 8. 6, 2, and 8 are all divisible by 2. And so we get negative 3 plus or minus square root of 11 times I all over 4. And last one, for 48, we have n squared minus 11n is equal to negative 12. Not in standard form, but that's okay. We can just add 12 to both sides. And we get n squared minus 11n plus 12 is equal to 0. We implicitly have a 1 here. Negative 11 and a 12. Definitely can't reduce that. So we have that a is equal to 1, b is equal to negative 11, and c is equal to 12. Plugging into our formula, we have n is equal to negative b. So negative 11 is going to be positive 11, plus or minus the square root of negative 11 squared, which is 121, minus 4 times a, which is 1, and c is 12, all over 2a, so we have 12 times 1, so 12. Evaluating our discriminant, we're going to have our 11 plus or minus square root, and discriminant comes out to 73. Put that into our calculator, all over 12. And 73 is not divisible by any perfect squares. So it's already simplified. And since this is simplified, we can't do anything more with this. So we just have n is equal to 11 plus the square root of 73 all over 12. So that's problems, what was it? 37 through 48, solving by quadratic formula. That pretty much wraps up this video. So I will see you on the next one.